There are three variants of the security vulnerabilities known collectively as Spectre and Meltdown. Variant 1 and 2 are different aspects of Spectre, while Variant 3 is Meltdown. Fixes for Variant 1, 2, and 3 have already been released, and the best way to stay protected is to keep your system up to date. But what are Spectre and Meltdown, and how do these fixes work? Let's address that by focusing in on Variant 2, which exploits a valuable computer feature called speculative execution. Speculative execution enhances a CPU's speed and performance with a feature that allows it to speculate on what tasks might lie ahead, even before the CPU actually makes that request. The speculative execution feature serves as a kind of scout, operating well out in front of the CPU's many other functions and capabilities. Its goal is to speed things up for the entire system by exploring lots of potential CPU tasks in advance. Imagine that as our scout reaches a spot in the road that branches off into a multitude of different directions, a flag person suddenly appears directing it to take one particular route. Unfortunately, that flag person turns out to be a bad guy who got access to the system through malware. And as we pass, he attaches himself to this scout without our knowledge, potentially allowing him to see some of what our scout sees along this part of the journey, including private information. Eventually, the scout will discover that a wrong turn has been taken and return to the beginning of the branch, but by then, the bad guy may already have what he was after. Fortunately, Intel has designed a new set of CPU hardware features that work with the operating system to create virtual fences, protecting the system and the data it contains from this kind of speculative execution attack. In our example, this solution would keep potential flaggers, or bad guys, away from the decision-making process entirely, so they can't influence the path our scout takes. The result is a solution that retains the many benefits of speculative execution while addressing the threat of Variant 2.